Hey, hello, welcome back to my YouTube channel. It's been a while since I made video. So today we are going to break down one of the most common and most dangerous vulnerability in modern web application is broken access control. This video has two parts. First part is source code review walkthrough where I will show you exactly where this vulnerability hide in real world code. And second, I give you hands-on demonstration where we will exploit this vulnerability and explain why it works and then fix it properly. So let's get started. So first, what is broken access control? Broken access control happens when the application does not properly check whether a user is allowed to perform an action, or the server touches user input too much, like testing ID, role, client side data, kind of. This lead to attack like viewing other user profile data, editing other user profile, accessing admin only feature like that. And one of the most famous form of this vulnerability is IDOR, insecure direct object reference. Explain is simple term. uh, Broken access control occur when user can act outside their permission, leading to unauthorized access sensitive data or functionality. So if user 1 change ID from ID1 to 2 ID2 and server just return the result, then congratulations, that is IDOR. So this exactly the vulnerability we're going to demonstrate. Now let's talk about where we've identified this vulnerability during source code review. When review code for broken access control, I always look for three pattern. First pattern, endpoint that fetch data by ID, like get profile ID, get user ID, like that. Where you see like that, notice what missing. You need to check whether the endpoint verify who is making a request and whether they have permission to view the object. If there are no ownership check, that is a red flag for you. And second, pattern number 2, server function that do not inspect the session or token. For example, in the demo code, the vulnerability endpoint uh, look like this. Vulnerability, yeah. Notice what missing. It's never check who the request is. It's never compare request username with profile username, and it's completely ignored the session token. This is the heart of broken access control. And now second pattern number 3, any direct database lookup without authorization. If you see something like this, without this, then you're lucky, found an IDOR. And this code are retrieve user data by ID from database, and this code are user can only access their own data. You see, without this means you found IDOR. Now practical time. Now let's jump into the practical. Let's go. This is a single HTML file called IDO register logging demo.html. It's a lab application. It has a simple register form and the logging form and profile page, and with vulnerable IDO lookup profile. I'll show you first how the vulnerability look from the user perspective, and then we'll review the source code to understand what wrong. First I create account and login. Create username. Okay, hackerman, hacker bye, and then set password, register. Okay, this is my username and this is my ID. Now I log into my profile. One left, we have register and logging, and on the right side we have profile and with vulnerable lookup section. This is important. So now at the vulnerable lookup section, let's look up profile by ID. While still login as a hacker man, I will type my ID 4, and that return hacker man on profile which acceptable. But how? But now here the problem. I will change the ID from 4 to 2 and then click lookup vulnerable button, and boom, we just got Bob profile data while login as a hacker man. And if this were real application, this could be somebody else personal data like financial data, private message, or anything else, and all we did was just change the ID in a field. This is a classic IDOR, broken access control vulnerability. Let's see how we would find this during source code review. Let's jump the here. It is vulnerable code. Okay. See, this function get profile vulnerable simulate a backend endpoint like MCU. Get profile ID 2 like that. Okay, let's break down it. Let's break down this vulnerable code. It's take ID and token as a parameter, and it's called the find user by ID to fetch the user record. If the user exists, it returns the profile, and the important thing is what does not do. It's never look at the token to figure out who is actual login, and also it never compare request profile owner with the current login user. Okay, this is exactly what we look for in a code review. Function that fetch data by ID but do not check ownership or access rule. In real code base, this might look like I show you. Look like this: Java, Python with no check. Like that, the essence of the vulnerability. Now let's look at the secure version. Here, what this function does differently. This function, what does differently? It's take token and call server get user from token. This simulate how real backend would decode a session or JWT to identify the current user. This simulate how a real backend would decode a session or JWT to identify the current user. If there are no valid session, it's written not authenticated, 403, 401, or it's still fetch the target user by ID same before, and this is the important part of this secure version of code. Now we are enforcing the ownership. It is the different. Now we are enforcing the ownership only if the profile user match the current login user name. We are return the profile. For multiple role system, you might also allow an admin. This pattern is what you want to see in the real application. First, derive current user from session or token, then fetch the object using its ID. Final check is this user allowed to access this object? If not, then return 403 forbidden. In this demo application, the lookup vulnerable button called the vulnerable API. There are also buttons show secure API call. Let's see the difference. Now I'm logging as a hacker man. I will type ID 3 in the lookup box. First I will check lookup vulnerable and we get curl data. Now I click show secure API call button, and you see the secure API user call get profile secure function which enforce the ownership check. Only the profile owner can see this. So as a hacker man try to see the curl profile data, the secure API responds with forbidden. That's exactly what we want to in real system. Okay, so that all for today video. If you found this video helpful, like, share, subscribe, and I have also include the lab download link in the description. Feel free to use it and try to the exploit yourself. So thank you for watching this video. I see you next time.
एक तो लाइक और शेयर ठोक दीजिए महाकाल का ठोक दीजिए 5000 लौटे दिख जाना चाहिए।